Hello viewers, welcome to this section where we're going to answer some multiple choice questions. So I begin. Question 1. Two mixable liquids X and Y with boiling points 78 and 100 degrees Celsius respectively can be separated by which method? Is it distillation? Is it fractional distillation? Now let's look at the question very well. We are given boiling point of 70 degrees Celsius. That is likely going to be ethanol. Ethanol, we know, boils at a temperature of 78 degrees Celsius. We are equally given a temperature of 100 degrees Celsius. That is likely going to be water. The substance is likely going to be water. So if we have ethanol and water mixed together, how do we separate them? To separate mixable liquids, having close boiling points such as this, we use fractional distillation. Ordinary distillation cannot be used because that only separates solutions having wide difference in boiling point. So since the boiling points here are close, then we have to employ fractional distillation. But then, which of the two solutions will be the distillate? Is it X? Is it Y? Let's look at the experimental setup of fractional distillation. If we look at the experimental setup, you find out that here, somewhere here, you have the receiving flask. Connected to the receiving flask is the condenser. Connected to the receiving flask is the condenser. What we will usually have here as a distillate is the one with the lower boiling point, which is going to be ethanol. If you separate ethanol and water, ethanol will be the distillate. The reason is simply because ethanol is more volatile than water. Ethanol will boil first when you heat the mixture. So ethanol will be collected as the distillate. So our answer to question 1 is fractional distillation and collection of X as distillate, which is option C. I go on to question 2. In question 2, which of the following metals cannot be regarded as a transition element? If you look at all this, we have chromium, we have zinc, we have manganese, we have iron, we have cobalt. Which of them is not going to be regarded as a transition element? The answer to this question is actually there. If you're wondering, the answer is zinc. Zinc cannot be regarded as a transition element. The reason is simply because zinc does not fulfill the definition for transition metals. Transition metals have partially filled d orbital, apart from being located in the d block. Okay? Apart from an element being located in the d block, it must also have partially filled d orbital. Let's look at it critically. We know that zinc has 30 electrons. If you arrange this into orbitals, we have 1s square, 2s square, 2p raised to power 6, 3s square, 3p raised to power 6, 4s square, and then 3d raised to power 10. This is the electronic configuration of zinc. If you take the last orbital there, which is the 3d orbital, arrange those electrons into the d orbital. There are 10 electrons there. Arrange the 10 electrons following Aufbau's rule, Pauli's exclusion rule, and On's rule. On's rule especially, where you have to arrange them singly before you start pairing. This is 5 already, 6, 7, 8, 9, 10. What do you see from all of this? The d orbital is fully filled. For it to be a transition metal, the d orbital must be partially filled. So this is what disqualifies zinc as a transition element. Question 3. The bonds present in ammonium chloride is or are what? Which of these bonds are present in ammonium chloride? Ammonium chloride can be splitted into ammonium ion and then chloride ion. Any compound you can split into positive and negative ion contains ionic bond. Ionic bond connects the ammonium ion with the chloride ion and responsible for the electrostatic forces there. Now in this ammonium you have there, ammonium ion consists of ammonia and then hydrogen ion. When hydrogen ion reacts with ammonium molecule, it forms ammonium ion. The hydrogen ion here is bonded to the ammonia molecule by dative bond. What bonds them together is dative bond. because here it involves sharing of electrons, and all the electrons shared are contributed by only the ammonia molecule. Now, the ammonia on its own, the ammonia there consists of 1 nitrogen atom and then 3 hydrogen atoms. All of these 4 atoms you see here are bonded together by covalent bond. There is sharing of electrons between the nitrogen atom and the 3 hydrogen atoms, and all the electrons shared are contributed by all the members participating. That is why it is ordinary covalent. It is dative because all the electrons shared are contributed by only the ammonia molecule. So as I have explained, as you can see from here, ammonium chloride contains these 3 types of bonds: ionic, covalent, and dative. I go on to question 4. The number of pi and sigma bonds in prop1-ine respectively are what? Propane. Let's draw the structure for propane. It's an alkyne having a triple bond here, bonded to these hydrogen atoms. All these bonds you see here have names. This is a sigma bond. This one, the one at the top here is sigma. This is sigma. This is sigma. This is sigma. This is sigma. Then these 2 bonds down there, the 2 lower bonds down there, this one is pi bond. The next one is also pi bond. These are the names of the bonds present in propane molecule. So how many sigma bonds do you have there? You have 6 sigma bonds and then 2 pi bonds. The sigma bonds are known to be stronger than the pi bonds. That's why in organic reactions, the pi bonds are attacked first. So the answer to this question is 2 pi bonds and 6 sigma bonds. That is option B. I go on to the next question, question 5. If 11.2 dm cube of a gas at STP weighs 14 grams, the gas is likely going to be what? We are given the volume of the gas, we are given the mass of the gas. How do we use those 2 informations to identify the gas? Now, as you know, all gases have their relative molecular mass. So we'll simply need to use these 2 informations to find the relative molecular mass of the gas. So how do we use these 2 informations to find the relative molecular mass? Now, we know that 1 mole of any gas occupies 22.4 dm cube. We know that 1 mole of any gas occupies 22.4 dm cube at STP. Now, 1 mole of any gas has a mass that is the same as the molar mass. 1 mole of any gas, the mass of it is the same as the molar mass. So if 1 mole occupies 22.4, the molar mass equally occupies 22.4 grams. So if that molar mass occupies 22.4 grams, therefore 14 grams will occupy 11.2. Or we say if 14 grams occupies 11.2, what mass occupies 22.4? When you cross multiply from here, our x is 14 times 22.4 divided by 11.2. When you finish up, you would have your x as 28 grams. 28 grams here is for nitrogen. Nitrogen has 28 grams. That the mass is 28 grams. 2 times 14. Each nitrogen atom is 14. So 2 times 14 is 28. So this is the solution to question 5. I go on to question 6. The time taken for magnesium to completely react with HCl at temperatures 10, 20, and 30 degrees was recorded as T1, T2, and T3 respectively. At the end of the reaction, it can be inferred that what? Magnesium is reacting with HCl at 3 different temperatures, 10, 20, and 30. Then the time taken for those reactions are recorded as T1, T2, and T3. How do those temperatures compare in relation to the time? How do the time compare in relation to the temperatures? Now, remember that the rate of a reaction is proportional to the temperature. That is generally speaking. Generally speaking, the higher the temperature, the higher the rate of reaction, and vice versa. At the same time, we also know that rate is equal to amount of a species reacting or produced over the time taken. From here, rate is inverse to time. Rate is inverse to time. Rate is also direct to temperature. From here, rate is inverse to time means what? The higher the rate of reaction means less time. A higher rate of reaction means the reaction was completed on time. So looking at 10, 20 and 30 degrees Celsius, the one with the highest rate of reaction there is 30 degrees Celsius. So 30 degrees Celsius, having a higher rate of reaction, will have the lowest time. So 30 degrees Celsius, that corresponds to T3. T3 there is the lowest. The lowest time taken is T3. T3 is less than T2 and T2 will be less than T1. A higher temperature, which means a higher rate of reaction, means the lowest time. That is the answer to that question. I go on to question 7. We asked to find the mass of diphosphorus pentoxide that will be formed on reacting phosphorus with 2.5 moles of oxygen. This is a stoichiometric calculation. For stoichiometric calculation, you must write the equation and balance it first. Otherwise, do not proceed. We are told that this compound is formed when phosphorus reacts with oxygen. Then we're also given that 2.5 moles of oxygen is reacting, and then we asked to find the mass of this compound that is formed. In solving stoichiometric calculations, write the equation and balance it first. So balance this by putting 5 here. After balancing the equation, I wrote what is given in the question and then what we asked to find under each of those who owns them, each of the substance that owns them. So how do we solve this calculation? To solve this, what I have down here is mass. At the top of the equation, I'm going to write the total mass of this. What is down here is moles. At the top of the equation, I'll write the mole. I'll use the moles of oxygen I see there. That is the procedure of solving mass-to-mass calculation. So 5 moles of oxygen produces, what is the total mass of this? You know, phosphorus atom is 31 times 4. There are 4 atoms there. Each oxygen is 16. 16 times 10, you have 160 plus 124. This will give 284 grams. Total mass of this compound is 284 grams. So 5 moles produces 284 grams. That's the principle. The equation is telling us that 5 moles will always produce 284 grams. So if 5 moles will produce 284 grams, then a 2.5 mole will now produce what? When you cross multiply from here, you have 2.5 multiplied by 284 over 5. Here 1, here 2. So dividing that, we have 142 grams. This is how we solve a stoichiometric calculation. Thank you for viewing. For more exciting videos, kindly subscribe to my channel.